Alright. So with concept, if you guys, there's 3 seats open here. If those on the end can't see, please feel free to throw on these 3 seats here or move your desk over. It doesn't matter. Either way, ladies, because I want you to be able to see the board. So you need to move your head. Now, we're going to go through 3 different types today. The first type is going to be an intercept form. Okay, we're going to look at intercept form. We're going to look at the fact that if we're given 2 roots and another point, can we come up with the function that represents this? So again, just like in the past, we had been given the function and then we were told to graph it. Now what we're going to do is this. Based on the problem, we're going to be able to take this information and write a function or a parabola that fits this data points. So based on these people tossing a ball back and forth, we can show the exact curve that's going to be given here using the roots and the third point. And let's show how in this problem we can see that. Can I get a reader? Vanessa, give me the first sentence, please.
2 people tossing the ball back and forth.
There you go. Second sentence. Okay, it can be modeled as a parabola. So right away, we know our function. It could look like this. By the fact that it says it's a parabola, it could look like that. It could look like that. It could look like this. Why did I write down all 3 forms? It could be any of them. Okay, we don't have enough information yet to say that it's intercept form, even though that's this topic right now. But it could be any of them. So 2 people toss the football back and forth. So already, I'm thinking about a person standing here, another person standing over here, and there's a football being tossed back and forth. Okay? The football being tossed back and forth. Next. Next sentence. Somebody besides Vanessa?
Wait, to read?
Yes, please. From person A.
Person A is 4 meters to the left of person B.
Okay, so this is clearly person 1 over here. This has got to be A because he or she is to the left of the other person. This is person B. We know the gap here is 4 meters. This is the kind of stuff you got to be visualizing as you're going through this problem. Next. From here. Juliet?
Person B stands 2 meters to the left of where we place the direction.
Okay, this is the hard part here. Person B, this is this person over here on the right, stands 2 meters to the left of what we consider the origin. So, based on that sentence, what can I do right now? Dirk. You could say that this person, sure, that person is good, but what can I show on my diagram? How can I do that?
Would you go from person B?
And draw what there?
A line?
What kind of a line?
A vertical line.
Thank you, a vertical line. This is really where my axis is now. So this is what's going on based on that sentence. Let's take a look. It says that person B is 2 meters to the left of what we consider to be the origin. So that's what you need to be drawing next. Again, person B right here is 2 meters to the left of the origin. Well, here's the origin right here. Again, the origin is 0, 0. It's where the axes meet. So if we know that this person is 2 meters to the left, that's what we have to draw next. So far, so good? The next says, consider if the ball is 3 meters above the ground level when it is 1 meter to the right of person A, find the equation that represents this path. This last part is the hardest part. What does that mean? If the ball is 3 meters above the ground when it is 1 meter to the right of person A. Do you want to come up and show me what that means? Because it's hard to describe. Somebody want to come up and show me where that would be located? Trayvon, is it a hand or are you just figuring it out? John, you want to come up and show? Where is that location?
The ball?
Give me a point, yes, for that last part.
1 meter to the right person. Right about here.
Very good. Awesome, John. Now, what John noticed already is this. 1 meter to the right of person A is like this, somewhere in between here. We don't know specifically because we don't have any tick marks lined up here, but we're just drawing a sketch. And we know that it is 3 meters in the air. So John is calling this a level of 3 right here. And he's calling this point, if we dash this down, where he's calling this point right here, 1, 2, 3, 4, 5. He's calling this negative 5. Again, this here, this person, person B, is located at negative 2, 0. This person, which is person A, is located at negative 6, 0. Now, the ball must be located at negative 5, 3. So again, the person, we consider the person, and this is the hard part that you have to visualize because this is like a physics thing. The person or the idea or the object is considered to be a point in space. So even though you see the person clearly has some height, right? The person has like a height of, 2 meters, if they're about 6 feet tall, 2 meters or so, a little less maybe. Well, we're going to consider the person as, or the ball as being thrown from here to here, okay? Or thrown from here to here, depending on which direction it's being thrown. And it's going through this point. Okay, so this is the parabola we are trying to model right here. Does everybody see what's going on? Again, the person is considered to be a point in space. This person is a point in space. We're neglecting their heights. We are saying that at some point in time, the ball is 3 meters above the ground. That's the 3 right here. When it is 1 meter to the right of person A, that's this point right here. Well, this is negative 5, 3 meters above the ground. There's that third point. So if we go back to the beginning of this lesson, we see, given the roots and a third point, well, clearly we have one root at negative 6, 0. We have another root at negative 2, 0. And we have a third point at negative 5, 3. So now we have 2 roots and we have a third point. So again, based on this data, what we want to do is figure out what the function is that represents this. Can somebody give me a suggestion of what I can do next? Any ideas? And I'm asking you to think outside the box here because we've never done this before. What can I do next to figure out what function we're going to be using here?
Oh, what type?
What type, and then exactly what it's going to be, what the values of A. If say we use the first one, we need to figure out A, B, and C. If we use the second one, we need A, X1, X2. If we use the third one, we need A, H, and K. So I'm asking you guys to figure out all the different parameters that we have. Remember, A, B, and C are considered parameters, things that can change. Okay, but they're not our variables in that sense. Our variables are X and Y. So which of these 3 forms should we use for this kind of a problem? And why? Anthony?
In the middle.
Why?
Because you have both X.
Absolutely. Again, you have the 2 roots here. Everybody see this? You have 2 roots and you have a third point. Well, which is the only one that uses the roots? The middle one uses the roots. So we're going to use the middle one here. We're going to also use this one later today, the vertex form. We're going to wait till we use standard form until tomorrow because this one is a little bit more complicated. Okay? But again, we're going to use the middle one. So here, we start by writing y equals a, x minus x1, x minus x2. Now, somebody else tell me, what does x1 and x2, or what do x1 and x2 represent? What do they represent? Trayvon? Very good. The roots are the intersections along the x-axis. So, where are the intersections along the x-axis? There. Good. Negative 6 and negative 2. Again, here's my first intersection at negative 6 on the x-axis and negative 2 on the x-axis. So I can immediately plug in those values. So here, I'm going to have x minus negative 6, x minus negative 2. And I know you can just make it a plus, so if you want to do that, go ahead. I'm just trying to show all the steps for the first example. Again, one of my roots was negative 6, my other root was negative 2, thus I plug in the negative 6 here and the negative 2 here. Minus a negative, everybody, becomes a positive. So just simplify so we have it in a better looking form. Okay. Now, I'm not done. What did I say we need to figure out? X1, X2, and A. So can somebody now tell me how to figure out A? And think about what we haven't used so far. Think about what we have not used. I'll go back up to the problem. We've used this point. We've used this point. Can we figure out A now, based on what we have not used so far? Go ahead.
3.
What do you mean, would it be 3? Why?
Because we have to go, the height was like You have to go up 3 and get that 5 and 3 and get that 5.
I understand what you're thinking, but it's not 3. It's a good idea. She's saying, is it 3 because our height was 3 we went up? It's not 3. Good idea, though. I like it. Derek? You can say FOIL. More work than needed. You don't need to FOIL. It's way more work than you need here.
Slope.
No slope here. Parabola. Clearly, guys, we have a point. Do we all agree with that? That we haven't used? And that point is negative 5, 3. Okay, so I'm going to write that down over here. Let's write down negative 5, 3. We've used negative 6, 0, and we've used negative 2, 0. So we can't use those again. We've already used them. If I know the value of x is negative 5 and the value of y is 3, what do I see in this equation that I have here that I can plug them in? Where can I plug in negative 5 in this equation in the bottom? Trayvon? Negative 5? And then the 3 would go where? In for the y. If I plug in a negative 5 here and here, because that's the x value, and I plug in a positive 3 there, isn't a the only variable left? So can I solve for a then? So let's do that. So in the next line, plug in a 3 for y, because again, this value goes here. The negative 5 will go here, and the negative 5 will go here, into those two spots. So we have a, negative 5 plus 6, negative 5 plus 2. Now just solve for a. Please do not FOIL this. Simplify in the parentheses first, and then multiply everything. Oops. So what do we get for a when we solve? Negative 1. Very good. And the last step is not to leave that, but to actually write the function. So the final answer for this function, we can use this line that's in black up at the top right here, but except just plug in for a. And a is negative 1. So I'm going to write it as negative x plus 6, x plus 2. Okay, and this is my actual final answer here. Again, negative 1, I don't need the 1 in front. I can just put a negative there. Again, negative 1 times the quantity x plus 6 times the quantity x plus 2. Okay, and that's an equal sign. The smartboard's off. I'm going to orient it in a second. I'll let you guys write something. Again, the idea here is the following. You're given certain amounts of points. Use them. Use them. If you were given an additional point, let's say another point outside of the roots, would you need to use it here? It would be extraneous information. Again, you were given the fact that it was negative 5, 3. That was your third point. If you're given a fourth point, you don't need to use it. So don't think that you always have to use everything you're given. Use whatever information is needed to get to the answer. Actually, I'm pretty sure I am. I hope I am. Yes, I am. Thank you for checking. Okay, let me orient this because that was off in the last one and it's bothering me. Okay. And now it's not. There it is. Okay. Let's try the second one now. This is a graphical example, still using intercept form. Oh, I shouldn't have said that, but you can see that by looking at your roots they're given on the actual function. Okay, so you're given a graph here, and you need to determine the equation of that graph. Again, you're given a graph, and you need to determine the equation of that graph.
Have you heard your voices on the recording? Your voices sound really stupid. Especially mine.
The voice always sounds different on recordings. No matter what, it sounds weird. Yeah, it's just that you don't hear your voice sounding that way. Yeah, it just sounds different. The first time I heard my voice, I was bugging out.
Yeah, me too, man. I was so mad. I was like, I do not sound like that. We should put all the ours in deep voices and just change it.
Talk about this the whole period.
It's on concept 25 today. That's what graphing parabolas. Alright. Yeah.
So here, I'm given a root here, and I'm given a third point. So start by listing, please. -1, 0, that's your first root. 4, 0 is your second root. And the point we're given is 3, -8. That's all right, that's all right. Okay, again, I'm given the roots and a point. So automatically I have to think of root form or intercept form. I'm going to shrink this down a little bit now that we've used it. Okay, so here I want to start with again, it's important to know which form to use. It is evident from this graph because you're given the intercepts to use intercept form. In a minute, we're going to talk about vertex form, and obviously, if you're given the vertex, you'll use vertex form. So here, we're given the intercepts right here, if we're given a third point right here. Now, I can automatically go ahead and plug in. Remember how last time we did it one step at a time? We plugged in the roots, then we plugged in for x and y. If you want to go ahead and do it all in one step, please do that. I'm going to do it separately just so we don't have any confusion. But again, don't waste your time if you can go right to it. So we can start with the roots. Now, x minus -1, x minus 4, those are my roots right there. So I can start with that. If you already noticed x minus the negative is a positive already, please make this x plus 1. Okay, again, you know the value of the roots are given up here. Use your roots. We've plugged those in so far. Now, at this point in time, figure out, I got a third point, I got to do something with it. So, what's your x value in the third point? What do we get for x in the third point?
3.
3. So that goes in this spot and this spot right here. I got to close this, sorry. And the y value, which is -8, needs to go in over here. And again, solve for a, just as before. What do you get for a, everybody?
2.
2. Good, you should get 2. There's going to be a -4 and a -8. Divide both sides by -4, a should be 2. Okay, so your final answer for this one is going to be 2, x plus 1, x minus 4. And again, use the form that has a plus or a minus for the roots here, not a minus and negative. Don't leave it minus and negative. You never leave things minus and negative. You make it a plus. Okay. Again, is this tough? How are we doing so far?
Good.
It's a very straightforward method once you do it a few times, okay? In the beginning, it's like, oh, what are we actually doing here? Now, again, this is only intercept form. We got 15 minutes. We'll get through vertex form. That's a very easy one. Standard form is a lot more work.
So are we also using that?
Right now, because we are given, again, we are given the roots or the intercepts. Thus, we are using intercept form. Same for the last one. For the examples 3 and 4, we're going to be looking at the vertex. So we use vertex form with the H and K. All right? Again, it depends on the problem. If you're given a graph, it's pretty obvious, right? We can see that. But the first example that we had, it wasn't as obvious which form we were going to use. Okay? Let's try the next one. So, for this one, we want to use vertex form. Again, we're in vertex form here. We're given the vertex and a second point. I'm going to fix this so you can all see it better. Sorry, Jason.
It's split in 3 places.
Again, we're given the vertex and we're also given a second point.
You just like to kill yourself in the
That's what we grab. That's why I have homework.
Do the next lesson. If you're about to fight, I'm gonna kill you. Yeah, I'm gonna kill you too. Hold up, let me strike myself. Whoa. So you beat me to the punch.
Now, here it tells you in the problem if the vertex is, so clearly you're using vertex form. Okay, it tells you the vertex, so go right to vertex form. Who can tell me what vertex form is? How do you say vertex form?
Isn't it AH squared plus K?
H
Close.
minus H squared plus K.
Good. Quantity x minus h squared plus k. Again, why do I say quantity x minus h? Because it's in. What are these things called? When it's in parentheses, you say quantity beforehand. Again, when you're speaking an equation or when you're using your words to express mathematical form, when you see a parenthesis, you say quantity. So if it was like the last one where it's x plus 1, x minus 4, you'd say quantity x plus 1 times quantity x minus 4. It represents the fact that you're using parentheses. So this is standard vertex form. You had a question before that. Do you remember asking? Now, based on what I know about this problem already, can somebody tell me what I should do? And think about the last example we did as well. Derek? Absolutely, very good. So he sees we have a vertex here, so plug that into the correct location. So tell me what the equation should read, Derek. Very good, Derek. And notice, all he did was plug in. Again, this was a positive 3 up here. What did it end up becoming? A negative 3. That's where the whole idea of switching the h comes from. He didn't actually switch the h. He simply just plugged in right here. If you plug in a positive 3, x minus a positive 3 is really x minus 3. And that's where the idea of switching the number comes from. And again, at the end here, it's plus a negative 4. In a minute, we can express that as just minus 4. Okay? So on the next line, just to be clear, express it with a minus 4. Because adding a negative is the same thing as subtraction. Again, the definition of subtraction from concept 1 is adding the opposite. So since we added the opposite of 4, it's the same thing as subtracting 4. Okay, somebody else besides Derek for the next part. I have a question.
Look at 3 was a negative.
What if 3 was a negative, everybody?
Positive 3.
Because it would be x minus negative 3, or x plus 3. Same as the roots we did last time. They switched those signs. Next part. Daniel?
Plug in 5.
Good. He notices we have a point, 5 comma 2. We have to use that point somewhere, so let's plug that in. Daniel, where does the 5 go in?
5 in there.
Very good. And the 2 goes in for?
Y.
Awesome. Again, I've simply plugged in at this point for x and y using the extra point, 5 comma 2. Finally, what should I do? Good. Solve. How did I get 6? What did I do? How did I get 4? What did I do? 5 minus 3 is 2. 2 squared is 4. That's this 4 here. Next, how did I get 6 in the next line? I added 4, because I have to get rid of this 4 before I can divide by that 4. So I add 4 to both sides, and then I can divide by 4 on both sides. Again, I'm not showing all these steps. Okay, this is really, this value, think of this as a 2. So you make that 2 squared. That's where the 4 came. Okay, algebra 1 here, that last part, guys. So if a is 1.5, our final answer is y equals 1.5 x minus 3 squared minus 4. And I have a clear representation of a parabola. I know a, I know h, I know k. Again, the goal is to find the missing parameters. That's today's goal. You find either a, h, and k, a, x1, and x2, or tomorrow, as we're going to see, you find a, b, and c. Yes? Yeah, I mean, you could do that, but you don't even need this equation. Actually, you don't really need this equation to graph it. You can graph it just from the given information up here. I might make one big problem where it involves both. Sure, yes. Julia's question was good. She said, well, what are we going to have to graph them afterward? Well, this is just like graphing in concept 24. Okay, so the problem says, John, please focus. trying to help you with your test. The problem says that you have to find the equation that represents the parabola and then graph it. At this point, you then just go ahead and graph it. You need to find your axis symmetry, which is 3. You know your vertex is 3, -4. You can find your y-intercept by plugging in a 0 here. So if you need to graph this, you just go ahead and use concept 24 knowledge next to graph it. Okay. Last one.
What's that guy doing? It's a girl.
So that, I think it's a guy with a backwards hat. I don't know. So the person is tossing a water balloon, all right? So a water balloon is tossed in the air, and is thrown according to the path shown in the graph to the right. What is the function that represents the actual trajectory? So again, what are we doing? We're fitting a function through all of these points. That's what we're trying to do here. We're trying to fit a function that goes through those points. And clearly we can see that projectile motion follows a somewhat parabolic path. Now, whenever we talk about projectile motion, we have to consider the fact that we're assuming there's no air resistance. Because if I toss an object across the field, it will go in a parabolic path, but it will not be symmetric. It will start off, and then it will start to die earlier, as opposed to the actual parabola without air resistance would look like that. Because of air resistance, it slows the ball down or slows the object down. This is an exaggerated version. This might end up over here, really. But you'll see that this portion is much less, and it's not symmetric anymore because of air resistance. Now, without air resistance, though, it should follow that exact path here. Okay? So, looking at this one here, I don't actually, so see how I drew this line on here? I don't actually know the line I was estimating, so let's just look at the points here. We're given a bunch of snapshots in time. So based on these points that I'm given here, what form should I use and what do I know? Those are my two questions here. What form should I use and what do I know? So, why would it be vertex form? Absolutely, I agree 100%. Take a look here. This point occurs right on one of my intersections at 3, 8, and it happens to be the vertex. So label it as 3, 8. So right away, she is correct, vertex form. What else do I need to use vertex form? Look at your last example. Another point. Very good, Juliet. Well, where's there another point here? At least one that we can kind of estimate. For example, here. This is somewhere between 1 and 2, somewhere between 4 and 6. That's a bit annoying, right? I want to find one that's actually on one of the hash marks somewhere. Right here? Close. It's not really on anything, though. It's like it's close to the 1 here in the x, and it's close to the 2 in the y. I might pick one that's a little bit better. 2, 7. Good. See how this is right on the number 2 here for x? See this point right here is exactly on the 2, and it's almost on the 7. 7 would be right there. Okay? Again, it's almost on the 2, and it's almost on the 7. This is the closest one. But again, it's up to you to choose. So if you guys did this on your own, and you chose, for example, this point right here. This point right here would be like 0.9 and 2.5. So if you want to use 0.9 and 2.5, that works. It's fine. It's absolutely fine. You can find your function based on that. But personally, I would use 2, 7 as my estimate. Again, because I know this is right on the 2, and the 7 is pretty much right there. Okay? So you're making yourself interpret it in a way, sorry, I'm trying to think of the right word. Interpret it in a way so that it is reasonable, okay? You're not necessarily coming up with an exact value, you're making a model of this. So we have the 0.38 and the 0.27. 38 happens to be the vertex. Thus, as Gisela said, let's use vertex form. Try this one on your own. Again, 3, 8 is my vertex, and 2, 7 is my additional point. for those of you that have been trying to do it all in one step, that's what your equation should look like if you plug it all at the same time. Again, the 2,7 is in blue, and the vertex is underlined in red. Okay, again, if you're going to do it all in one step, that's fine, but please be careful. Many people can confuse things. They'll switch the x and the h, or switch the k and the y. Okay, again, the coordinate goes in for x and y. What do you get for a when you solve this?
-1.
-1, very good. Okay, I'll go through it real quick. This is going to be a +1 plus 8. Subtract 8. A is -1. Okay, again, make sure PEMDAS. Do what's in the parentheses first and then square it. So this 2 minus 3 is -1. -1 squared is back to +1. So my final answer, oops, not h, plus 3. Okay, again, why don't I have a number in front of here? Good, it doesn't matter, it's -1. -1 just means a negative symbol. Okay? To conclude, we got about 4 or 5 minutes. I'll give you your homework, give you a second to get started. But just to conclude, there are 2 things that we should note. Okay, first, both of your answers for intercept form and vertex form can always be expressed in standard form. Remember that. So the answer that we just got, we had negative quantity x minus 3 squared plus 8. If you FOIL that out and combine like terms, you can always express your answer in A, B, and C form, or standard form. Again, if you have vertex form or if you have intercept form, either one of those, you can always express it in standard form. Now, the next part is the more important thing. And this is, I'll let you guys write for a minute, and then I'll discuss it, because I want to make sure we understand what's going on here. Again, the first part is just saying that you can go from intercept form to standard form and show it that way, or vertex form convert to standard form. This should say 2 points. I was in Typo City last night, sorry. 2 points. So here's what's important. If we look at vertex form and intercept form, to get the values of h and k, you need the vertex, which is 1 point. Again, so once you have 1 point in vertex form, you have h and k. With the other point, you can plug in for x and in for y. So you only need 2 points for vertex form. Again, you need the vertex and another point. But for intercept form, how many points did we have? 3. We had 3, because one of the roots gives you x1, one of the roots gives you x2, and the third point gives you x, comma, y. Again, so here, you need a root, you need the other root, and you need a third point. Again, if you're given a vertex, you only need one other point, one other point, one other point. Okay? In root form, you need 2 roots and another point. Again, here you're going to need 3 points. Here you're only going to need 2 points. This is the exception, the top one, for vertex form. Traditionally speaking, you think, okay, we're going to need 3 points. Even for standard form tomorrow, we're going to need 3 points. Okay? But again, for vertex form, you only need 2 points.